Hello, everybody. Good morning, good afternoon, and good evening, depending on where you are. And thank you for joining this Neo4j Live. Today we cover building a semantics-based recommender system for ESG documents. And I'm very happy to have Astrid Krickl as guest today. Hello, Astrid. How's it going?
Hello, Alexander. Thank you for having me. Going good so far.
It's great. It's great. This is another one of those sessions that we couldn't have at Notes, but were so good that we wanted to have him later on. So we are now talking today about ESG documents. If you are watching this and think, hey, what is an ESG document? I think it stands for environmental, social, and governance, if I'm correct.
Yes, perfectly right.
And that's I think together with a couple of global initiatives, part of a way of becoming more sustainable and more I guess more green as a planet or as a society living on the planet. So I think there is United Nations have a couple of sustainability goals. There's the Green Deal from the United European Union. There are probably some other initiatives as well that are all kind of like tying into that, and I think that's the baseline. But if you're not interested in sustainability, if you're not interested in all of that, it's still an interesting session because we talk about semantic-based recommendations. So I think that's nevertheless very interesting. So I'm looking very much forward to today's session. I'm wanted to encourage you again, if you watch this live, please post your questions, comments, everything in chat. We'll have a look at that, and we can surely answer some of your questions, some of your comments, discuss a little bit. So there's time for that. And yeah, but before we dive in, maybe Astrid, do you want to introduce yourselves a bit? Do you want to say a few words about maybe who you are, what you do, and maybe why graphs matter to you?
Sure, yes. So yeah, I am Astrid Krickl. I am from Vienna. So I'm working for Semantic Web Company. So our main product is Pool Party, which is a knowledge graph management tool and a lot of things more. So we will dive into that a little bit later in the
Cool.
call.
Yeah.
Um, yeah, so graphs in general is a really interesting topic because it fits in all of the different industries and everyone can really benefit from using graph technologies. And so to make this happen, also with Neo4j together, it was an initiative within our company to see what we can do because we are more on the semantic side and what we can do with property graphs. So this arrangement came together, and I was one of the engineers who did go through with the setup essentially. Yeah. So I'm here at Semantic Web Company as a data and knowledge engineer. So my main focus, what I'm doing all day, is working with customers together on very different use cases. We have a wide variety of customers. So, of course, we also have a lot of ESG relevant customers, I would say, but also a lot of other different customers with yeah, a lot of use cases and a lot of things to work together on.
I can imagine. Do you? I don't know if you talk about this later on, but right away, I had this ESG topic. Is that something that came up recently and has a lot of traction, or how do you see this part of the the data landscape, I guess, or the policy world rather?
Yeah, so I think it gained a lot of movement as well during the last years, also during COVID already.
Mhm.
Here in our company, we have also an ESG working group, and we have some initiatives also on these lines.
Cool.
That is why I also used for this demo the data actually we had within our company regarding ESG documents. So we have a lot of movement, and we also hope for getting a lot of new customers along these lines, and we really want to help them with their journey through this whole ESG topic, which is gigantic. So you really need a lot of people to understand what we need to do there, and what also makes sense to do there, where also knowledge graphs and semantics, of course, play a big role and can really make your life a lot easier if you're using it in a good way. So this is also some projects we currently have going on to build some prototypes and frameworks there to really help
Cool.
companies on their ESG journey. Yeah, and as I said, so for this project, we used the use case that was already in the company to see what we can do also with a different technology stack,
Mm-hmm.
and go on from there and see how we can use that also in a different setting.
Oh, that's very cool.
Yeah.
What's and again, stop me if I'm taking away of your presentation. But what's the biggest challenge you'd say when working with ESG documents?
I would say on the one side, of course, the variety. So
Hmm.
I mean, every bigger company should also report on this topic. So you have, of course, a wide variety of like oil and gas industry, but you also have like the bank and financial sector,
Hmm.
and you have a very different focus for all of these companies, and to really see through all of this information and then really get a gist of what you have to do as a company is really hard for a lot of customers actually. Um, so I would say this is one of the main challenges, to really understand what we can do, what we can help also with this reporting topic, and like in a bigger picture, of course, how can we be more responsible for our planet and really have a better understanding of what can be done and what has a big impact.
Yeah, yeah. I think that's a very important point. I mean, everybody can do a little bit, and I think everybody, if you know what you can, what's already there, what's working, what isn't, and how the processes maybe how they connect together. I think that's something that is maybe not even a big effort for somebody if you actually look into your data and see, hey, actually, if we do this or that, then we save money, and we also do something good. So it's like a good
Yeah.
win-win kind of scenario. Yeah.
Yeah, right. And also a lot of this data that is really necessary to have, like also like CO2 emissions, and other production factors you can have, is really interesting to analyze, and it is really a big amount of data. And this is also where knowledge graphs come in quite handy, because you
Mhm.
you can use the structure you have within a graph very easily to put together all of the information you have in just one point, and then you get out numbers also quite easily, like if you change this and that stream in your production,
Mhm.
what does the change in the emissions, and this is something we can model with a graph very easily. Whereas if you work with like relational databases to really scrap out this data, you sit for days.
Yeah. Yeah. And it's very visible, like you said. You have the benefit of that, and you directly see how's the correlation. What does one um, mean for the other, for the outcome, and where can I put something else in here. And yeah. And then
Yeah,
generally, right? I mean, it's not only that. It's we look at the content of data. We can look at policies. We can look at structures, and other things. So it's a wide field. So lots of things can be done, and it's great. I think I'm very happy that this is happening, and I'm very happy that this is something that's now obviously with graphs, or through the power of graphs, it becomes a little bit easier for everybody who's dealing with it. So
yeah,
that's good.
yeah. I'm really looking forward for the next years, what comes up in this section of work,
Mhm.
and what firms also come up with, how we can deal with this topic as well.
Cool. Yeah. Yeah. Me too. Great. Let's not just go into this discussion. Let's maybe come back a little bit, and talk about what you had prepared for today on the how to build a semantics-based recommendation system. And yeah, maybe let's have a look at that. You have, I think, a couple of slides. Maybe we do that first, and as I said, if there are questions, any comments, anything, maybe you are watching this and already working with ESG type documents, and let us know. It would be interesting to hear your thoughts, hear your experience. But if you're generally working with knowledge graphs and analyzing data and implementing that, also always a good, interesting to hear.
Right. Yeah. So I will start sharing.
Yeah, I see your screen. Here it is.
Okay.
Perfect.
Okay, so yeah, for today's talk, as we already mentioned, so it is about building a semantics-based recommender system for ESG documents. So let's jump right into it. So I prepared a small outline. So I want to talk about what is the semantic web, what are property graphs, how does pool party work, and as well how does Neo4j work. So we have here, of course, best of both worlds, and then we want to combine those. And then I will talk also about our use case, so what we are doing here with the ESG documents. And then I will tell you about the details of the integration we have here, about our analysis, our data we found, and also really running the semantic search and recommendations. And I also have prepared a live demo, sorry, for later. So I will then show you what our integration looks like.
Cool.
So semantic web and property graph. So as I said, we have here two different approaches to model knowledge graphs. So on the one side, so this is more of my domain where I come from, we have the semantic web that is, of course, heavily standardized. So we have here a lot of RDF, OWL, we use Sparkle, Shackle, SCOS. So we have a lot of standards we are using here to also ensure interoperability. So we want to have reusable data that can be also used in other knowledge systems. We can do reasoning on top of all of our graphs through these standardized approaches we have. And of course, what is the goal is that we want to have semantic descriptions of things. So we don't want to have just words or nodes. So we really want to have some details here, and which we get through our semantic descriptions. So this is the one side, and the other side is actually the property graphs. So these are modeled, of course, in a little bit different way to fulfill a little bit different use cases. So the main use case for property graphs is that we want to make use of the graph traversals. So what we want to learn is about how a knowledge graph is structured and how we can go through the knowledge graph. Instead, on the opposite, what we want in semantic web is what the graph tells us, so what we can learn from it. So what we can do with this graph traversals. So also what we can model in property graphs is, of course, the properties which are on the edges. So this is a feature we don't have in the semantic web as prominent. And so we can also model our data a little bit less weighted, I would say, because we can put properties directly on edges, and that has some shortcuts more or less for the modeling part. And what we also have with the property graphs is introduced by Neo4j, the Cypher query language, which is very different to Sparkle, because it really focuses on what graph traversal we want to find and what we want to build on. So it is a very nice language. I really enjoy using Cypher, actually. And it's just really a very easy way to go through actually a lot of data. So we really have these two words, and they have different use cases. And what we wanted to do also within this project is we want to, of course, get the best of both of them. So we really want to get this the features of the graph traversals, but also to have the semantic layer on top. So I can introduce a little bit our products. So first of all, I can tell you a little bit about Pool Party. So as I said, Pool Party is a knowledge management, a knowledge graph management system, and we also have, of course, some other functionalities, but everyone starts small. So with Pool Party, we always have our honeycomb structure, and we would start in this tile, in the blue tiles here, where usually our customers start to draw their graph and do taxonomy management and a little bit of ontology management on top to get a little bit more data through their taxonomy in there. And then you can also do some basic graph data management and really work around with your knowledge graph you have and get comfortable with it. And as soon as you have built your foundation with your knowledge graph, you can use the Pool Party functionality of the extractor to really use your taxonomy now to find annotations and classifications within documents. So this is our natural language part of the product. So we really are able to make text analysis with the knowledge we have in the background, which is the taxonomy and the ontology. And we can do really nice things with these two parts of the product already. So we can really work with a lot of metadata. We can infer knowledge. We can use the structure of the taxonomy to find to find really details also within documents, which is not hallucinated like in ChatGPT, for example, but which is really with a solid knowledge in the background. Next, we have the what we can build with both of these. So when we have our taxonomy and when we have our documents with a lot of knowledge in the background, we can already build a semantic search and recommender systems. Really easy with the knowledge we have. It is easy to build these kind of integrations. But normally that is not the end of the journey. So normally in a company, you have a lot of places with documents and knowledge, and you want to bring that in one by one. So as you start small and grow bigger, you probably have more and more documents you really want to bring in, and more systems you want to integrate. And here it comes to the turquoise tiles here on the left, where we really can work with heterogeneous data, put it together, using data ingestion, mapping, linking to really get all of this data into our Pool Party, into our system. And by doing that, we can really then build also really advanced semantic AI applications. Just from going through the taxonomy ontology process, we are really able to build big systems with it. So far to the Pool Party semantic suite. So as I was talking about our natural language capabilities, so what we can do is the semantic tagging with Pool Parties. So I wanted to quickly show you what I mean with that. So this is our Pool Party interface, what you see here. And we have a lot of labels, and we also have a lot of relationships within our system defined. And with our tagging capability, we can find the different labels of a concept within a document. But what we can also find is by using all of these relationships, the semantic relationships between different concepts, we can use that to also find other tags and annotations. So we can really use the whole semantic graph to find a lot of knowledge within documents or within text to build a semantic layer, a really strong semantic layer. Yeah, so coming to the Neo4j database, so our other main piece of the integration, of course. So we have our Neo4j database, which is the market-leading graph database. Neo4j is using a property graph model. So as I said, that is the second part to the semantic modeling. We have the property graph modeling. which is a little bit different. And what Neo4j is really nice with is, of course, the high performance and the scalable functionalities with clustering and also sharding. What also comes with Neo4j is the really convenient Cypher query language, which is really nice to use. And it is really expressive, so you can do a lot of things very easily, and it's also very powerful. So you're really able to write very complex queries quite easily. Overall, that was also my experience, of course. The Neo4j database is very easy to manage. And also, as I built an integration, I would also say it is very easy to integrate with other systems. So as Neo4j is a property graph model, we are using not property graph models, but very normal knowledge graphs. We needed to gap this bridge. And to do that, we were using the Neo-Semantics add-on for Neo4j. So with Neo-Semantics, it is possible to work with RDF data and Neo4j. So if you would try to work with RDF data and just put it on Neo4j, it doesn't really work because Neo4j expects an RDF star format, which is, again, a little bit different. So you need to transform this kind of RDF data into the format that Neo4j needs. And this can be done with the Neo-Semantics, which is an add-on written by some Neo4j colleagues. And we use this to serialize our data and import it to Neo4j, and you are also then able to export it again. Neo-Semantics is also quite strong, so you can do a lot of mapping, and you can also do some basic inference and model validation using Shackle.
It's developed by Jesus Barraza, who I'm also having the pleasure of doing another series going meta. I don't know if some of the people watching now know it. So we usually in this series we kind of like bridge regularly the gap between the RDF world kind of and the graph world or the Neo4j world, and talk about various things around the world, from taxonomies to semantics to other things around there. So if you're interested in that, that's maybe another interesting session that's happening regularly.
Yeah, thank you. Yeah, I had also the pleasure to meet Jesus already. He also helped me very shortly with this integration using the Neo-Semantics.
Great.
Great. Yeah. So we needed to use the Neo-Semantics to make the bridge between RDF and RDF star working. So I can talk a little bit about our integration architecture. So of course, here's a lot of things are happening. So I will tell you what are the main parts. So on the one side, we have our pool party modeling server here, which is our main pool party server we are using for the taxonomy management, but also for the tagging. So we have a lot of people that can work on a knowledge graph. We can also have AI working on it. Also some knowledge specialists, and really have our taxonomy and ontology ready to go. And then we have our other centerpiece is our Neo4j server. So what we are doing within this integration is we are using our pool party server to produce auto tagging, to use auto tagging on documents, and then we store the documents and the annotations within Neo4j. And exactly to bring this data that comes from pool party, which is RDF, into Neo4j, we are using Neo-Semantics. And on the other side, we also publish our taxonomy and ontology as well on the Neo4j server. So we have our documents, the tags, and how the tags are related together in our Neo4j server. And now we can start querying all of this data for another application. And for this, we have our pool party recommender server. which queries the Neo4j server and displays what are the results. So there we can build, for example, some search applications, analytics, or recommendations, which can be used by knowledge workers or other interested people. So so these are the main pieces of the integration. So now I can talk a little bit more about the use case. So we have our ESG use case. So as Alexander said before, so ESG stands for environmental, social governance. And it is a guide to help companies to perform responsible business strategies. So a big task of the ESG is, of course, reporting and writing. And this is also where a lot of standards and definitions come in that you can use then to build up your reports. So this is on the one side, there is the SDGs, which are the United Nations Sustainable Development Goals. And there are also GRIs, Global Reporting Initiative. So there is a lot of definitions. So this is not a complete list, but these were the ones where we really focused on for this use case. And yeah, as I said, so ESG reporting is a major topic for enterprises. So it is really something that enterprises have to do some work on. And for that, there are multiple tools and multiple standards available. And now you have to go through the struggle to find the ones that you want to use. And so we come to the use case of the document analysis. So for example, as an ESG manager, I want to create an ESG report. So how can I find relevant information to complement my report? So as I said, it is really a jungle of information. So this is where we want to fill in a little bit. So on the one side, we want to find documents, like which ones are the relevant ones. And on the other side, we want to explain them. So how do they relate to my report? So what standard applies right now? Where should I put in more work? So more of this explained side. And also what you can see within our demo is which SDGs relate to my report. So to really find which of the SDGs are the relevant ones, also the company is really focusing on. So how does it work? So as I said, we built a enterprise recommender for the insights into this ESG data. We have on the one side, we have our knowledge model and our annotated documents. And on the other side, we have our Neo4j database. So what we want to do is to use this Neo4j database and put on a semantic layer, what we get from pool party. And with Neo4j, we are now able to use the graph traversals to tell us how the documents are related and how the documents relate to the SDGs. And here I have some screenshots also from the Neo4j database. And here we can see, for example, we have a document in the middle. So the purple one is the document. And we have all of the semantic context around this document, around it. So all of the blues and the yellows and the pink one is something that has to do with the document. These were found by the pool party extractor. And what you can see, for example, between these two, we have a related relationship. So this is that comes from the taxonomy. So this is a SCOS relation that is modeled within the taxonomy. So not only we get a context what this document is about, but we also get other information which is within the context even. So that is something you don't get out of the box from Neo4j, but you get that from pool party. And what we are now able to do is we can work with document similarity. So we have, for example, the purple ones are again documents, and we can now infer in between documents how they are similar. And we can do that directly by both of these documents have a concept in common, but you can also go other paths like this one, where you go over narrow broader relations, where you go through the taxonomy. And the more relations you have between two documents, the more interesting it, of course, gets, and the more similar it gets, because they are both in a very similar context. And what we can also find using our semantic layer is how a document relates to SDGs. So that is, of course, can be also found directly. So this concept, or the goals that are defined in SDG 13 are something that is also mentioned within this document, which is in the context. But it can also be that you find an SDG over, again, over the taxonomy relationships, which can be through a concept that is also found in the context of the document, which is then related to another SDG. So I can show you a demo, of course, of what we built here. So I talk now a lot about the theory of what we did. Are there any questions so far?
There is one question from Olivier. He wants to know if you can recommend a ESG data set to start with. Is there something available? I mean, how is there something that people can take, or do you have something you used to work on initially, or is that all something you have to, kind of like collect yourselves during the process?
So in my case, we have our ESG working group that works a lot on data sets, and they are really, as far as I know about the process, it was a lot of manual curation actually. So it is really downloading these kind of reports we have, and getting them together. So I am not totally aware of a very good public data set, as for the moment.
Yeah, I know that there was I had them as a guest as a research group from the University of Athens, and they work on a project called Sustain Graph. They specifically work with the United Nations sustainability goals, and they have like also kind of like collecting a knowledge graph out of that. I'm not sure if they are actively. I mean, the public is the project is public. I'm not sure that data set is something they share, but that's maybe another thing to look at. In this case, they presented at Nodes as well, so that's something you can find. Sustain Graph is what it is. And then there is another question or comment from BL33_19. They say, thank you for sharing your knowledge. Considering the linguistic diversity in ESG reporting, how does the system ensure precision and meaningful recommendations across multiple languages? Maybe that's something we can show in the demo. I don't know, or something you can answer.
Yeah, that's something I can answer. So for now, the demo is in English.
Mhm.
However, so multilinguality is something that is very natively supported by Semantic Web. So the way multilingual operations work is in general that you have, when you build a taxonomy, you build all of your, so you build up the concepts with the URIs, and the URIs can have different labels in different languages. So it is a little bit of a knowledge engineering task, of course, to bring in the right labels for the right things in different languages. But it's not impossible. There are also like translation services and things like that. So this is on the modeling side, you have to do that, and on the operation side, then is if you have a multilingual knowledge graph. So within Pool Party, it is possible to use the extractor to annotate automatically, and so the Pool Party extractor can detect the language, but you can also share the language with the extractor to use the right part of the taxonomy for the other language. So it is very natively actually to have the tags in different languages. Also, you always, when you find a tag, you get the URI, which is the unique identifier of a concept. And then you can also query by URI the language you're interested in. So even if you don't have the documents in different languages, you can produce an output in from the metadata in different languages if your taxonomy allows for it.
Cool. Yeah, perfect. Thank you very much. Then I guess, yeah, let's have a look at the demo.
Yes. Let me share my other screen.
Mm-hmm. And if there are any more questions, any more comments, then obviously keep them coming. We can have a look at that later.
Okay. So now this is our pool party Neo4j search interface. And what we see is we have here a lot of different reports. And so it is parts of reports. So how the data set looks like. So it is a lot of these sustainability reports from a lot of firms. And they are all split up by paragraph. So what we actually annotate is a very short text, what you can see here. And you see also in blue is the ones that are found by the extractor. And here on the right, we also see these are the tags that actually are found by the extractor, and they are also highlighted here. So it is very short text. So it is a little bit of a, it is of course a little bit risky to work with such short text because normally you're missing a little bit of context.
Mm-hmm.
But in this case, it worked quite well. And what we can also see is our recommendations of our SDGs. So this paragraph of the Flex Limited annual report is also talking about gender equality, quality education, and reduced inequalities. And this is because we can infer this knowledge through our taxonomy. And what we also can find now is our similar documents. So these are the documents that are in a very similar context to our Flex report. Yeah, so this is the ones we can find. And as you can see, so to really fulfill the use case, if you now would search for this kind of report and you want to know, okay, which SDGs is this firm working with, you would see that. And if maybe this is not enough input for you, you can also go on to another report. For example, this one by Baker Hughes Company. And you see this one is more about the SDG 7. Yeah, in this case, we don't have any similar documents. Yeah, so what we can also do in this interface is, which is very convenient. So here on the left, we have a faceted search, which is from our taxonomy again. So we can, for example, search by geography. So we can select a country, and maybe we are only interested in healthcare articles. So now we come very easily with 2 clicks down from 25,000 documents down to 14 results that are relevant to this use case. And if we go on that again, we get from this Shionogi companies, sorry for my pronunciation, and we see that this firm is actually working on no poverty, good health and well-being, decent work, and economic growth. And we again have some similar documents we can go through. So this is the live demo. Yeah, we have now, I think, a lot of time for questions.
Theoretically, yes. It's very cool. How do you? So this is all set up, and the data is basically based on documents. Is there a reason why you slice them up in smaller chunks, or is this the one you showed earlier? Or is this because it says here, for example, page 32, section 1? I guess there is a page 1 to 32, and there are more sections. Is this how does this slicing, was this part of the data processing, or was this
Yes. So it was, as I said, we have some internal projects going on, and this is also the data set is one result of one of these internal projects.
Hmm.
And we got the feeling that if you have as you can see, I mean, here we are on page 70.
Yeah.
So in the first rounds to really work with this document, it was a little bit hard to really get a lot of context out of them, because I mean, with 70 pages, you really
Yeah.
talk about a lot of things.
Yeah. Yeah.
And then we decided to really split up the documents by sections, so
Hmm.
that you have one chapter, as you maybe say, to really get a little bit more context out of that. And in this process, it was also split up by paragraphs. I don't remember quite the reasoning behind that. However, it was really giving a lot of insights, actually more insights than per chapter, into these documents, to really get a good picture of when the document is talking about what.
Hmm.
And this is really nicely can be really nicely done with our extractor to navigate through the different parts of the document. So yeah, it was a design choice. So that is
Yeah.
very true.
Yeah, yeah. No, that
Yeah.
makes sense. That makes sense. And then you can filter, but you can also search. I see it there at the top, so I guess you can do both. I mean, depending on
Yeah,
what you have, you could. Oh yeah, even with that's nice. Yeah, so you get that. I mean, I guess we need
we need some results.
we
Yeah.
need yeah we need maybe exactly a little less um filters, and then yeah, okay, cool. And then you filter it down. Cool, very good.
Yeah.
Yeah. And then it shows you similar documents. Cool.
Yeah.
Yeah, and then you can click through. Yeah, that's very neat. And then you can explore through the different documents and the data that you have.
Exactly. Yes.
Yeah.
Yeah.
Cool. I see a couple of questions, so let's look at these. Matt asks, let's say you wanted to use something similar as your semantics-based recommender as a sensitivity labeler. What's some advice you would share to overcome, in quotes, not enough context?
Hmm. So I would definitely say it has a lot to do with your taxonomy and the quality of your taxonomy. So because in a lot of enterprises, it is really hard to get good metadata, and it always comes down to the quality of the taxonomy.
Mhm.
So to really have knowledge workers that really know the field you're working with is really valuable to the quality you get out of the results. So that is, of course, one thing. The other thing is can be fine tuning. I mean, it always depends on your setup. So to really work a little bit with the parameters, I guess, like sensitivity. What was the phrase? I'm sorry.
Sensitivity labeler, yeah.
Yeah.
Sensitivity. Yeah.
I think especially for that, there can be also a lot of manual annotation done, to really get a lot of more labels and annotations for also the learning, if you're using something like machine learning.
Mhm.
Um, that that is really also important. So a lot of manual effort actually can improve the quality of results like that.
Yeah. I mean, I know that this is obviously something that's needs a lot of preparation and work ahead of time. So it's worth it, though. I think
Yeah.
oftentimes if you spend the extra mile and prepare your data and make sure that everything is in there, and especially streamline um, on labels, especially because you might have the same thing with five or even more different descriptors sitting on it, so it's always hard, and okay, you have, it's the same thing, but somebody calls it this, somebody calls it that, somebody calls it something else entirely, and then you always have a data mess at some point. And but if you clean it up first, and then it goes into your knowledge graph, then it goes into your knowledge system, that helps a lot to overcome and to make the outcome even better, and to help you in the process, I think.
Yeah, exactly. I mean, it's especially the work with synonyms or also acronyms. So there is a lot of things established normally in a firm, and it also evolves over time. But I would also agree it is really worth the effort, because once you have a system set up that works quite nicely, you get the benefit out of it really quickly. So yeah.
Yeah, absolutely. Yeah. Matt continues to say, right on, thank you. Practice makes perfect. Yeah, I think that's right. I mean, and that's always right. I think specifically with graphs and here probably as well is you don't have to land perfectly with the first try. You can always give it a shot and see what you get out of it, and then you can start working on it. Just don't assume that if you do it like this, your first shot will be perfect, and don't assume that your first shot will be flawless and will be running as performantly as it could. But at least it will give you an idea, right? And you get some knowledge out of it. You see, okay, this is technically you are on the right path, and then you should do you should do some data cleaning and some like you said orchestration of the
Yeah. I mean, adding to that, so also with this integration, as I said, it was basically the whole last year we were working on it. So
wow, yeah.
uh, of course, we also didn't start it as a one-shot wonder. So that was not
Yeah.
it.
No? Oh, that's a shame.
I know.
Yeah. Yeah, cool. There is another question from Olivier. He asks, did you take advantage of the Neo4j vector index features by implementing this?
That is a really good question. So we did some indexing for the labels so that the search is working, of course.
Mhm.
Um, I am not sure if this is the vector indexing or if there is different kind of indexing.
Probably vector indexing was something that we released later or mid last year to help out with this additional capabilities of searching specifically, and I think that's the point of Olivier here. So similarities, and that's what you showed in the data model is you can show similarities inside the graph, but you can also use vectors to point at different points and see, okay, there's a similarity between these, and this could like add an additional level, I would say, or maybe even an additional performance boost if you combine the vector index on top of what you already did. But maybe that's something for a next phase.
Yeah, it really sounds very interesting. So yeah, I will take it on as a next step.
Yeah, maybe.
Yeah.
Cool. I don't see any other questions. Yeah, cool. Yeah, Olivier, exactly. Then let's maybe have a look at that, and then we see, or you can see if that makes sense in this case here. Anything else you wanted to share, Astrid, today?
I think that was everything. I have one last slide. Yeah. Okay.
Yeah.
Let's do that. Right. So of course I wanted to talk about the advantages of the integration. So really the unique selling point of the integration is that we can use the natural language processing capabilities of Pool Party in Neo4j, because with Neo4j alone, you don't get this kind of capabilities. So you would also so you always need another tool for this.
Mm.
And with the very simple integration with Pool Party, you get it very easy. So you get the semantic layer with the taxonomies and ontologies from Pool Party. And then you get this native representation in Neo4j, and then you can really use the power of Neo4j, which was really also interesting to just play around with. So I don't know how many afternoons we spent to do some cipher querying and get better results. So that was always very fun. Yes, right. And really with playing around with the graph patterns, we get a lot of these similarities and the recommendations. And we can very easily see how close the nodes are to each other. And this is also possible through the structure of the property graph, because we were able to write also our extractor results directly into the property graph. So we get some numbers out of the extractor, how well a concept fits onto a document. And this is what we also used to filter through all of the results we got to really get the highest similarity between documents. And it is also very easily possible through the usage of the properties on the edges. And the same goes, of course, for the recommendations, which is done in a very similar way. And it is very natively to use that in Neo4j with the properties. As when you build that in Sparkle, it's a little bit more complex actually to also get this kind of information to it. Yeah, of course. We have the relevancy and the weights. So this is exactly the things we get from our pool party extractor. So we can use really the power of the extractor here to have a really nice sorting. And of course, all of this integration is very easy to adapt to different use cases. So as I said, it's a very easy, so to say, integration. It is very easy to change the documents and also the taxonomy in the background. And then we can adapt a little bit the graph patterns, the weights. It depends on the document. So as I said, we had a lot of iterations also with the taxonomy, with the Cypher queries, how we structure things, how it works also with the taxonomy, which relationships are interesting or not. So we played around there quite a lot to get this result, but it is really a very easy thing to adapt it to other use cases. Yeah, so this is my last slide. Yeah, very, very nice for having me. Thank you, Alexander, again. These are my contact details also on my LinkedIn. And this is the blog from our company. So if you have also any further questions, you're very free to write me an email and also connect with me on LinkedIn. Yeah.
Cool. Thank you very much. I mean, I wanted to know. I have one more question, but maybe I'll take one more from the audience first. There was another one from FXPO1. They want to know, when you start the whole knowledge-based process in a company with lots of existing docs and information sources, how do you optimize the first steps, or what would you recommend of doing first? What's a good starting point when diving into that process?
So our first starting point, also with our customers, is always the taxonomy and the ontology. So it's always the first step to see what there is already, what can be done with the things that there are, and if there is nothing, that is also not a problem. So we can build also a taxonomy. We have different strategies to do that. And then go from there. So the first step is always taxonomy, and then we usually can do a little bit of a prototype, see how well the extractor works with the documents you have, and get a little bit of a feeling for the data, if the data actually fits the taxonomy. And exactly these steps is a lot of back and forth actually between is it a problem with the documents? Is it a problem with the taxonomy? And really find out and get the taxonomy right, and then push in more and more data. So these are normally the steps. So also with this integration, it would be exactly the same. So this first the taxonomy, then do a little bit of a try around, get the queries right, and then push more data and see how well it works, and then sometimes go back to the roots again, adapt the taxonomy,
Yeah.
and also adapt the queries within your application and get that right. So it is always a process.
Yeah. For this project, did you use an existing ontology or taxonomy, or did you have to create everything yourself?
So this is a taxonomy that we used is our own ESG taxonomy that was also developed by the ESG group within the company.
Hmm.
So we were able, and ontology, so it is both,
Yep.
and we were able to use that.
Okay.
So for this project, we didn't develop a taxonomy, and also we had also some iterations with documents, I have to say, and some documents worked better, some worked not so great. Yeah, and then we shifted to this data set, which I think really works well with the taxonomy as well. Yeah.
Okay. Cool. And then there's one question that basically took away my question is, again, also from FXP01 is they wanted to know what's the integration with LLMs and chatbots like? I mean, everybody talks about something these days, and I think this here is sort of a little bit hinting at it could be maybe connected with an LLM, or it could be used with a chatbot. Is there something you are trying out at the moment? Is there something you are maybe have already done? Is there something you can share in with this in the AI world as a add-on sort of?
Yeah, so of course, this is also a big topic in our company, where we also have several initiatives going on because the interest also from our colleagues is very big.
Yeah.
So we have actually one demo, which is Pool Party meets ChatGPT, um, which I would need to find to show you. Give me a second. I will just talk through it. So the thing is, what we say in our company, it is always very important to see the bigger picture. So what you have with ChatGPT um, is that you get a lot of wrong answers. I think everyone knows that.
Hmm. Yeah.
It's very, very common. Also, I myself also use ChatGPT because it's super funny.
Yeah.
And and I think that is also no shame really, but it is always important to see that these LLMs are language models and it is language prediction. So it just it just guesses the next word.
Hmm.
So how good can it be? That is always the question. And oftentimes also the feedback we got is that ChatGPT um, uh, doesn't really take context into consideration. So that is a really big problem. And of course, we as a knowledge graph firm, we are working with knowledge, we are working with
Hmm.
context. It is a big opportunity actually to really go into there and use best of both worlds and combine two approaches. And I found the demo, so I can show you real quick.
Yeah. Sure. Let's see it.
So we have our pool party meets ChatGPT, and we have as well. It is also on our ESG data, and we can here ask different questions. So, for example, this one, and so which form of renewable energy contributes to the most to the worldwide energy mix?
Hmm.
And we get now ChatGPT's direct answer.
Oh
So
yeah. Okay.
it's
Cool. So you can do a side-by-side comparison, basically.
yeah.
Yeah.
Yeah, exactly. And what you see, it's in this case, it's kind of short. So normally ChatGPT is a little bit more vocal.
Yeah.
But yeah, we and in our integration, what we do is we are using our extractor, getting more context out of the
Mhm.
question, and then sending it also to ChatGPT, and then we can add context really easily, and the knowledge that is built up from in this question, and then we get a much more clear answer
Yeah.
with a lot more context.
Yeah. It's very cool.
Yeah, and what you can see also the blue ones is these are the concepts that are also mentioned within our taxonomy.
Hmm.
So you can also read them up, and yeah, so you get a really better answer. So we can and then what we also have is this the temperature. So
Ah.
this
Okay.
is
Yeah.
this hallucination
Yeah.
topic.
Yeah.
So you can also, yeah, you can a little bit play around. It's kind of funny to get
Yeah.
a answers.
Go crazy, ChatGPT.
Yeah. Yeah, but sometimes it's funny. So if you ask like really direct questions about like I don't know, what is it, the CO2 emissions of a certain country, and then you can ask 3 times and you get 3 different answers. So it's always really funny.
Yeah, yeah, cool.
Yeah, so yeah, you can play around here a little bit, but it is really it was a really nice showcase also, what you can do with a little bit of knowledge in the background, and I think that is really valuable also for other companies and
Absolutely.
other use cases, to take that into consideration. Also because normally you have a lot of documents within your own company and a lot of knowledge, and then to use an LLM that is trained on public data, it oftentimes doesn't make so much sense. So it is really about the knowledge what you also want to have in your company to really get good answers, and not asking 10 colleagues to get the real answer.
Exactly. Yeah,
Yeah.
that's very important. That's something we see but predominantly, obviously, also at Neo4j, and I think that's something we have advocated a lot about in the past. To say, okay, yeah, LLMs are great, but you have to, you have to connect it with your own data, with your own knowledge. Otherwise, it loses all the, or it misses all the concept, or all the context, and
Yeah.
all the information you have locally at your company, and it doesn't give you any advantage of using it just for the sake of using it, and that's very, very important step. Mark asks which ChatGPT versions you're using. Do you know on top of your head on which ChatGPT this one
I
is based on the
think
demo?
I think that was GPT-3.
Yeah,
Yeah, but
no.
don't take me too serious.
Yeah, that's fine. Cool. Thank you very much, Astrid. Thank you for the time to prepare the overview and the demo, and for the ad hoc demo you now also showed in the answer. That was very cool. Thank you very much for that. And yeah, thank you for the presentation. Thank you for the integration with Pool Party Neo4j. I hope that's something that is going, on for a long time, and adding more and more, and obviously, hopefully, everybody is that watches this now is interested, and then you can check it out. So I think there's a good, a good, interesting point of connecting these things together, and making knowledge available, and expanding the footprint there, and to get more information out of what you already have in your company, in your data, lying around, potentially unused, and that's a great way of looking into that, and making more out of these documents, PDFs, whatever you have, and using that more. Yes, cool. I'm not gonna do any stream next week, but as I said, the Going Meta series continues, and on the 5th of February, we will do the next episode 25. So if you are interested in more semantics, more ontologies, more taxonomies, and how they work together, and potentially, how a knowledge graph can help there, then join us on the 5th of February in 2 weeks' time. And yeah, until then, thank you everybody for watching. Have a good rest of your days, and hopefully we'll see you soon next time. Thank you very much.
Thank you.
Thank you. Bye.